Hello everyone, welcome to my TikTok channel. This is Chemistry Guru. So today we'll be talking on about chemical bonding, and there we're looking at three learning objectives, which I'm going to work with you. So the first one is saying how do metals and non-metals bond to each other. Now, for simplicity's sake, I will tell you this: always think about metals as parents, and then think about non-metals as children. What this is going to help you out. So think about metals as parents, and then they give their time, energy, money, and the likes, and children they accept. So with that, we can now move forward. Now let's take an example. Let's take lithium as an example. Lithium is a metal that has atomic number 3, so it means that the number of proton and neutron and electron is 3. Now, because it's a metal, it tends to give out. And now, when they are giving out, they don't give out their proton. Always remember, the proton is there in the nucleus. You don't give it out, you give out your electron. So every time an element, an atom carry out reaction, they carry out reactions with their electrons, not with their protons. So now, it's going to give out one of its electrons in order to form a stable configuration. Now, if you remember, the first shell has 2, second shell 8, 8, and so forth. Now, for it to have this stable configuration of 2, for the electron to be stable, they enter in pairs. Electrons stay in pairs. Now, 2 is a pair. It has 1 extra. That is what it can give out. Now, it gives that out. What that happens is that it now has 2 electrons. So because it has 2 electrons, it means that it has more proton than electron. And you remember that protons are positively charged, electrons are negatively charged. So therefore, because it's having 3 more positive than 2 negative, it means that our simple mathematics, 3 minus 2 is going to give us +1. So it means that it's having 1 proton more. So because of that, lithium automatically would be written as Li+. In chemistry, we don't write the 1. If it was 2 that it gave out, then it could be Li2+, for example. Now let's go to the non-metals. So let's go to the non-metals. Remember, non-metals are kids. So we take, for example, chlorine, for example. Right? We're using chlorine, for example. And then chlorine tend to have, or let's use fluorine. Let's use a smaller non-metal. So let's take fluorine, for example. Fluorine tend to have atomic number of what? Of 9. So fluorine has 9, and then it means that it has 9 proton and 9 electron. Positive, negative. Now, if you remember what I just said in the last one, I said fluorine is a non-metal, which means the child, it tends to accept. So what happens is that when lithium gives out this electron, fluorine accepts it. So it means that it has 10 electron and then 9 proton. So it means that in overall, fluorine has a what? Has more electron than proton. That gives it the negative. So the moment it becomes like that, it's now called a fluoride ion, or it just fluoride ion or fluoride. And then we have lithium ion. So the moment there is a charge, it is no more an element, is no more whatever is now called what do I say is now called an ion. So when they bond together, they form what we call an ionic bond or electrovalent bond. So how do metals and non-metals bond together? They bond together by what? Giving and accepting of electrons to form an ionic bond. How do non-metals bond to each other? Remember, they are children, like we said. Non-metals are children. So how do they form? How do they share? How do they bond to each other? Simple. Because they are children, they can only accept. They cannot give. They are not working. They don't have a job. Nothing. They rely on their parents. But this time around, they want to bond with each other. What did they do? My daddy gave me £10. My mommy gave me £20. So what do? We share these pounds together, and then we become good friends. We bond together. So, in other words, no metals share electrons. That is how they bond. They bond by sharing electrons. So we're going to give a very simple example with that. So let's say, for example, we have so let's give an example of a bond, a non-metal bond. So I'll also tell you that they share electrons, leading to what we call covalent bonding. So let's give an example. Let's consider H2S, for example, which is hydrogen sulfide. Now sulfur has electronic configuration of let me just write it here, 286, right? And then it tends to have 16 proton and 16 electron. Like we said, no metal, what do? They accept. So for it to have a perfect or a stable configuration, it needs to accept 2 electrons, right? For it to have a perfect configuration. So at that point, is looking for who is going to who is going to share that 2 electrons with. So then we have hydrogen and we have hydrogen. In this point, hydrogen is acting as a non-metal, because hydrogen has just 1 electron, and hydrogen is going to share its electron with sulfur. So we can have something like this, sulfur, and then we could have 6. Let me change that to 4, and then it has this, right? So it could have an hydrogen coming here, an hydrogen coming here with this 1 electron, which is 1 electron. So they are going to share that electron in order to achieve this. So that gives us to H2S. So that gives us a covalent bond. So how do non-metals bond to each other? By sharing electrons. It's as simple as that, by sharing electrons. How do you write the formula of a compound? The formula of a compound is written more like a ratio. So for example, we could have just like the way I've already explained this thing in all this we've done. So just like the way we have the lithium coming together with the fluoride to give LiF. So that's how we write the chemical formula of a compound. So they come together, showing us their valencies. They call it valencies. Or you say, okay, let me just use a singular instead. And they tend to exchange valencies. Right? And then they come together, cancel out each other, and then we get LiF. So if we have, for example, magnesium, and then we have chlorine ion coming together, like I said, they are going to exchange valencies. So that will be Mg, we take the +1, and then we have the chlorine taking the +2. So that gives us magnesium chloride. We'll do more on writing chemical formula later on, but for now, this is what you need to know now. Thank you very much. Bye bye.